Wyko Profilometer is an optical profiler. It uses non-contact interferometry for surface topography measurements. The profilometer offers two different modes for measurement. The first mode is PSI and can measure a 2 mm sample with a 3 nm resolution. The second mode is PSI, which can measure a 160 nm step with a 3 angstrom resolution. There are four main parts to the profilometer: the objective lens, the stage, the keyboard, the computer and TV monitors. Let's also introduce our lab users. Before we can do anything, we must first start the software. As you might notice, the illumination is turned on as soon as the software is started. This can be seen by the reflection on a white piece of paper. Once the software has started, we can now operate the profilometer with the keyboard. You do not ever need to touch the profilometer. Everything can be operated from the keyboard. We can raise or lower the objective lens by rotating the focus knob. Rotating right moves the objective lens up, and rotating left moves the objective lens down. Pressing the fast button can change the speed. Do not crash the objective lens into the sample. We can tilt the objectives by pressing the tilt button and moving the joystick. This is how we can rotate the fringes or adjust the fringe spacing. We move the stage by moving the joystick. Pressing up on the joystick moves the stage out and vice versa. Pushing right on the joystick moves the stage left and vice versa. You can think of the joystick as actually moving the objective lens. The button on top of the joystick moves the stage fast for coarse adjustment. Tilting the joystick without pressing the button gives fine adjustment. We load a sample by pressing up on the joystick in order to bring the stage out. We place the sample on the stage, then move the stage in by pressing down on the joystick. We want to position the sample directly under the objective. We then lower the objective by rotating the focus knob to the left and pressing the fast button. You want to lower the objective lens until it is about half a centimeter away from the sample. To remove the sample, rotate the focus knob to the right. Move the stage outward by pressing up on the joystick and remove the sample. Before we perform a measurement on our sample, we need to calibrate both the PSI and PSI samples. This should be done at least once a day in order to ensure accurate data. The PSI calibration sample is stored in a plastic box. We store the PSI calibration sample face down to prevent contamination from landing on the surface. The sample is placed on some buttons to prevent it from coming in contact with the box. Mount the calibration sample on the stage with the label facing you. We begin the calibration by clicking on the calipers. We select Auto Calibrate. We select all modes. Leave these boxes unchecked. The step height value is printed on the calibration standard and is 10 microns. To focus on the standard and observe the fringes, we open the intensity window. Go to Hardware. Make sure the 5x objective lens is selected and the 1x field of view. Also check to see that the filter is set to PSI. This slider controls the illumination. It can also be controlled by the page up and page down keys on the keyboard. Pressing page down will increase the illumination, and pressing page up will decrease the illumination. We increase the illumination until we see red in the screen. Then we will decrease illumination until the red is eliminated. Now focus on the calibration sample by pressing the fast button and rotating the focus knob to the right slowly. The first image you will see will probably be a false image from the bottom of the calibration sample. Continue raising the objective until you see the true surface. Now you can use a joystick to scan across the sample to find the step. This is a step. It is a rectangle that is etched into the calibration sample, and it is 10 microns deep. Center one side of the step in the window. Move the focus until you can see the fringes. If you are pressing the fast button, the focus is very sensitive. You must move the knob very slowly. We can rotate the fringes by pressing the tilt tip button and moving the joystick. We tilt the fringes until they are perpendicular to the step and until we have 2 to 4 fringes in the field of view. Decrease the illumination to eliminate the red color. We can adjust the focus until we have the best contrast. We also want to focus on both the top and bottom of the step to make sure we can determine which is higher. Move the focus knob to the left and we should see the fringes appear on the lower step. This is the lower step. Move the focus knob to the right and the fringes will appear on the upper step. We always begin a scan with the fringes on the upper step of any substrate. Before clicking finish, let's recap the steps we have completed. 1. Place a step height standard in the field of view. 2. Orient 2 to 4 fringes perpendicular to step direction. 3. Adjust fringes for best focus at top of step. 4. Select the step height value. Step 5 is to click finish. So let's go ahead and do that. Once we do, the profilometer will perform the calibration in the VSI mode. You need not worry about the results of the calibration. Once it's finished calibrating, replace the VSI sample in this box. Be sure to place the sample face down on the buttons. This is a PSI calibration sample. We keep the sample covered to prevent damage. To remove the cover, twist the screws. A point will come when the screw will lift up. The lid will capture it. This prevents the screws from being lost. Be sure to place the lid face up. This will prevent any contamination from coming in contact with the lid. The PSI calibration sample is an optical flat. It is extremely important to be careful with the flat and prevent the sample from getting scratched. We return to the intensity window. Go to the hardware window, choose filter. We must select PSI low mag. We now calibrate the sample the same way in which we did the VSI sample. Refer to the VSI calibration section of this video for reference. The only difference is that the fringes are at a 45-degree angle. Let's recap the steps to completing the PSI calibration. 1. Place a reference surface to field of view. 2. Adjust 2 to 3 fringes at a 45-degree angle for best focus. Step 3 is to click finish. So let's go ahead and do that. The profilometer will display the results of the calibration. You need not worry about them. Remove the PSI sample and place the lid back on. You can check the hardware to check magnification, filter, and field of view. We open the measurement options window. We have to make sure that we have the same magnification and field of view in the measurement options window. We are doing a VSI measurement, so we have to select the VSI radio button. You can choose the resolution you want to do. There are options for both VSI and PSI modes. The settings for each section only matter if we are doing that kind of measurement. In our case, we are looking to do a VSI scan. So let's take a look at the VSI options. If you click on the VSI options tab, there are many choices. The 1x speed gives you higher resolution but takes longer. 5 microns is the minimum backscan at the 1x speed. You must guess the correct length of the scan, but it must be at least as large as your features. You can also select the modulation threshold. This controls how sensitive the machine is to detecting fringes. Let's take a look now at the PSI settings. But remember, the PSI settings only matter if we are doing a PSI scan, and the VSI settings will only take effect on a VSI scan. Averaging number, when it's turned on, will take the average of this number of scans. The modulation threshold is the same as in VSI mode. The vibration detection threshold automatically compensates for vibration. Leave the intensity selections blank, phase and wrapping at standard, reference blank, measurement filter at default, and the phase algorithm at standard. The other tabs are for advanced operation. You should not use them until you are familiar with the basic operation of the machine. In the measurement options window, you can also select intensity and calibration from the bottom of the menu. You can either click the new icon or Control-N to begin a scan. The machine will then show you the results of the scan, and you can select different analysis options from the toolbar. One of the most useful options is a 2D analysis. This is similar to a stylus profilometer. This will show you the profile of your sample along a cross-section that you choose. You can measure the step height by clicking on the triangle and moving the cursor to the feature of interest. You can move the coordinate windows. The vertical distance will be displayed on the right and the horizontal distance on the top. You can also zoom in. Position the cursors on either side of the area you want to zoom in on. Right-click between the cursors and click on Zoom In. All the windows you open are saved. You can select any window by going to the window menu and clicking on any window. The 3D icon gives you a 3D image of your scanned area. By left-clicking in the window and moving the trackball, you can rotate the 3D image. If you right-click on any window, it gives you a menu. You can choose analysis options, which changes the way the machine interprets the data. Plot options allows changing the way in which the machine displays the image. In plot options, you can zoom the image, change the scale, and change the appearance. In analysis options, you can choose a variety of analysis operations. One useful operation is data restore, which interprets missing data. To save your data, go to the File menu, go to Save Dataset As, and save your dataset on the server Grover. When you save your data, you are saving all the raw data, not the window that is open at the time. When you're ready to stop using the system, remove your sample from the stage. Be sure to move the stage back in. This helps prevent injury from occurring in the lab. Open the intensity window and set the intensity to 0. If you do not do this, the light will remain on. Now you can exit out of the program by going to File, Exit, and clicking Yes. After watching this training video, you should have a good understanding of how to calibrate a VSI sample, calibrate a PSI sample, measure your own sample, and use analysis tools. If you have any questions, please direct them to the trainer for its equipment. Do not direct your comments to Charlie.